This is a quick screencast solution of the graphing slopes and equations for mathematical relationships. The things that are done here are things you should expect to be able to do on the quiz that you're going to have for your first quiz and pretty much throughout the year. So I've gone over how to calculate slope in one of my other lectures, videos that I've made. It's certainly something you should have had in math, but I just want to go over it here. So to get the slope of a graph, we're looking at the change in the vertical or y-axis component over a given region compared to the change in the x-axis component over the same region. So whether you have points or not, you would choose 2 points from your line of best fit, not the data points you collect in an experiment, because those data points all have experimental uncertainties in them. The line of best fit is the best representation of the model that we've got. So I chose point 1 here and point 2 here. So point 2 is at 9 meters, point 1 is at 5 meters, point 2 is at 4 seconds, point 1 is at 0 seconds. So my slope is 1 meter for every 1 second. Notice the slope should have units. The units mean something, and that's actually the last question here. So the overall equation is p for position is equal to the slope, which is 1 meter per second. Again, notice I'm including units multiplied by time. There is no y-intercept, so you could put plus 0 meters in there, but you don't have to. The y-intercept in this case means that's the starting position. That's your position at t equals 0 seconds. The slope of this, as you can probably tell from the units, represents the object's speed. For number 2, we've got something similar, except our graph has got a negative slope. So when I choose my points, point 1 here and point 2 here, I have my final point at negative 10 meters per second. My initial point is at positive 10, so I subtract off a positive 10. That gets me negative 20 in the numerator, and then 5 minus 0 seconds is in the denominator. So my units over here are meters per second. My units down here are seconds. So this rather odd sounding unit is negative 4 is the number meters per second. And that's a type of acceleration. So the velocity here is equal to negative 4 meters per second times time plus our y-intercept of plus 10 meters per second. So if you plug in any time for this, you'll be able to get the velocity at that instant. And assuming the trend continues, you could do that beyond the 5-second range. What does the slope of this represent? Well, it's how velocity is changing with respect to time, and we call that acceleration. You may not know this, but actually the displacement, which is how far the object moves in a given time, would be the area of the graph. So we would look at the area in here and the area in here. In this case, since this area is negative, this area is positive, the displacement after 5 seconds would actually be 0. Number 3, use the following data to make a graph on graphical analysis for salary versus number of years they've been employed. So I put this on the last page. I'm going to go down there now. So my graph looks like this. Notice I do scale from 0. I think it's important initially, if you remember the misleading graphs ed puzzle I had you do, to not cherry pick and not take a small range of data. So in general in physics, for a while, we're going to want to scale from 0. We will change that probably at some point, but this doesn't just zoom in on the data. So in this case, they've got something that looks like an equation here, but it's not the final equation we want, because our y-axis variable is actually salary, our x-axis variable is actually experience. So notice I've got a title here, I've got the columns labeled, which is why the labeled in the graph itself. I've got a line of best fit, and again, I've got it scaled from 0. The line of best fit, the title, and the scaling all are down here in the graph options part. So make sure you know how to do that. Going back up here, we can find that the equation is going to be salary is equal to $2,296 per year times E, which is experience, plus $18,770 as your y-intercept. So this tells us that we have a salary increase of around $2,300 per year and a starting salary around $19,000 per year. What do you think is the total meaning of the area of the graph? Well, it's kind of cool. If you look at, say, the area from here to here out to 8 years, And to get that, we'd have to take a rectangle and a triangle, but that would be the total amount of money you've earned in that 8 years' time. So, pretty neat. For this graph, to get the slope again, similar to what I did before, I took this as 0.2 and this is 0.1, 7 minus 0 students, 0.7 minus 0 hours. I get 10 students per hour who are falling asleep. I know, I'm shocked as well that students fall asleep during my lectures, but that happens. And that's what that says down there. This is the equation. Sleeping students was 10 students per hour times time plus 0. Now, if I use this equation and put in time of 3 hours, I would predict that I would have 30 sleeping students. So that's basically everybody sleeping. So again, hopefully this helps. I'll attach a PDF along with this, and the goal is, of course, to make sure you have an understanding of both graphs and the mathematical relationships behind them.